So decimals, as I said, are very interesting concepts in maths, and we want to um just simply look at some terminologies around decimals. So first of all, decimal. What is a decimal? Decimal usually is a form of fraction, okay, but we write it using what we call the decimal point. Okay, so 1 over 2 is a fraction. But if we don't want to use a numerator and a denominator and we want to express it still as part of a whole by using the decimal point, then we can find the real value of this fraction, which is zero point 0.5. Okay, so the point is a very important thing in decimals. Now, technically speaking, every number after the point defines what we call the decimal places, the number of decimal places. Okay. After the point, okay, anything before the point is usually zero or a whole number. Okay. That makes it a whole number. Zero is a whole number. So anything before the point is a whole number. 0.673, 2.414. This bit is whole number. Anything before the point is a whole number. Anything after the point, it defines what we call the decimal places. Okay, so we can have one decimal place, two decimal places, four decimal places, and so on. It's simply the number of columns that comes after the decimal point. Anything before the decimal point is a whole number. Anything after the decimal point is actually a fraction or represents part of something, part of a whole number that is not quite completely a whole number. So that is all what we can say about decimal points. So when it comes to decimal points, I have another lesson where we will be looking at them in detail. Decimal points will help us to do what we call rounding of numbers. So we'll come to rounding of numbers. So look out for that lesson later on. Rounding of numbers is very important because sometimes you are given a problem to solve and then the examiner will tell you how many decimal places they want your answer to be or how you should round up your number. Okay, rounding up numbers go in hand with what we call significant numbers or significant places. So we will be doing that too in detail. We will be doing that in detail. Then, of course, there are some basic operations with multiplying decimals, adding decimals, dividing decimals, and so on and so forth. Now, we will have a standalone topic that is looking at everything that have to do with decimals. And that will be a big topic. So we'll be looking at um, decimal places, approximation of calculations. We will be looking at significant figures. We'll be looking at significant figures. And then we will also be looking at intervals. Intervals. Okay, all these are very, very significant to understanding decimals, and we will be looking at them in a standalone topic. But here, what I want us to quickly do is to see how the operations of numbers with decimals go about. Okay, so a very quick and rough guide to handling decimals. Adding decimals first, or adding or subtracting decimals. It's simple. We started looking at numbers and we were expected to be able to add numbers like 12 plus 4, 16 minus 3, and so on and so forth. But what if they are decimals? It's still simple and we are still expected to be able to do that. 12.15 minus 3.68. We should be able to do this. 14.71 plus 6.89. We should be able to do this, okay? The thing I want to tell you here is that whenever you are having to add decimals without a calculator, which often happens in a non-calculator paper, all what you need to do is to align your numbers in a way that respects what we call the place values. Okay, so if I have 0.0143 and I'm told to add this to 1.25, I'll have to position them in columns such that I respect the place value. And what I mean by that is that if I've been given this to add to that, I'm going to do 0.0142 and I'm coming to do 1.25. I must align the decimals, and don't forget when it feels like not all the numbers are in the column. Like for instance, it looks like there is an empty space here. Okay, so a student will be forced to bring the 2, 5 here to cover every space, being afraid that these numbers will drop off. But no, you align the decimal points, and what you are actually doing is that you are respecting the place values. You are respecting the place values. So here, this is the ones, okay? And it is 0 for this number. But here is what we call the tenth. The first position after the decimal is the tenth. The next one is the hundredth and the thousandth. For this number, this is the ones. The next number is the tenth, and this is the hundredth. So by bringing the decimals together, you are making sure that the tenth is aligned with the tenth, the hundredth is aligned with the hundredth, and so on and so forth. That is what you need to watch out for when you are attempting to add decimals or subtract decimals. Okay, so that is for adding or subtracting decimals. Very short and concise. It's something that we are probably very familiar with, so I'll not waste much time on it. Let's go on to multiplying decimals, multiplying or dividing decimals. What do we need to take from here? What do we need to take from here? 2.4 times 1.6, or 3.2 times 0.04. Okay, so I've been given these decimals and I'm taking a non-calculator paper and I'm expected to work this out without a calculator. What do I do? It's simple. It's simple. Pretend as if there are no decimals. So if there are no decimals, this will be 24 and this will be 16. But in your pretense, you need to account for what you did. You remove one decimal place from here. until this looked like 24. You removed one decimal place from here until this looked like 16. So what you have done to this problem is ignored two decimal places. So that is fine. Go on and multiply your numbers as you can, 24 and 16. Let's multiply them. We get 384. So I ignored two decimal places and pretended as if this is 24 and 16. I've multiplied them and I've gotten 384. 384. So the two decimal places in all that you ignored, you have to bring them back. So 1, 2. So 3.84. That is how I can easily multiply decimals without a calculator. So first, discount the decimal places, go ahead and multiply them, and then bring back the decimal places to account for what you did so that the value is respected. As I told you in earlier lessons, in maths, we respect values. You don't change value of anything. You can manipulate or rewrite it or represent it in a way that is easy for you to work with. But whatever you do, remember to do something that will bring them back to their same value. And that is what we have done. So here we first ignored the decimal places, went to multiply them as if they were whole numbers because it's easier to multiply whole numbers, then brought back in the decimal places to maintain the value so that we don't change any value. Let's do the same for that one. And then subsequently, you can set examples for yourself and solve it in your free time. So 3.2 and 0.04, I'm going to pretend this is 32 by discounting one decimal place, and I'm going to pretend this is 4. If I want to pretend this is 4, I've actually ignored two decimal places to make this 4. So let me go and do my 32 times 4. 128. 128. But how many decimal places did I discount for me to pretend they are whole numbers and work it? I got 1, 2 from here. I got 1 from here. So 3 in all. So I need to bring back the 3. 1, 2, 3. So what I'm getting is 0.128. And if it's 0.128, then I can write it properly as 0.128. So that is how I'm able to multiply 3.2 by 0.04. And I get my 0.128. And that is all. It's the same thing you do with division. Discount the number places, the decimal places, go and do your normal division as you will do for whole numbers, and then bring back the division, and that is it. So we will end our introduction of decimals here. As I said, there are so many dedicated topics to decimals. We will be looking at them subsequently in our lesson, but to keep this a simple introduction to numbers, this is what I want to share with you regarding decimal. The final bit on this topic are percentages. Percentages. Remember, the topic was fractions, decimals, and percentages. Fractions, decimals, and percentages. So what are we looking at percentages?